A Simplex converted to a Great Western Railway Prairie Tank Part 36, a different way to mount the boiler to the frames. The engine needs to be on its side for this job, so I'm removing the chimney, removing the dome, and pulling out the petticoat from inside the smoke box. I'm quite pleased to see that it does come out. When I made the new petticoat pipe it was a bit tight in there, but it's okay. This engine has done quite a lot of running and it's extremely dirty, very oily, very grimy, so we'll have to do something about this, but I'm not going to do anything for the moment. First of all, I need to fit the boiler. Currently the boiler is sat in between the frames with the ashpan in place, so the first thing I need to do is remove the ashpan, just to make sure that I can easily remove the ashpan with the boiler in this position. In this clip, using a screwdriver, I'm positioning the boiler so that the holes which take the blowdown valves are exactly in the centre of the holes on the frame. And I also need to make sure there's a gap between the front of the boiler and the frame stretcher. Luckily, the position of the boiler worked out okay. In this clip I'm using my caliper to get the accurate size of the hole in the frame, because I'm about to make a couple of washers to centralise the position of the blowdown valves at each side. And for that it's over to the lathe. Here's the chuck in the lathe, just sat there. And here it is, fitted with a piece of phosphor bronze. So why am I wasting a piece of phosphor bronze for this job? I could use a piece of steel. I'm using the bronze because once I've made the washers and used them to locate the position of the blowdown valves in the frames, they can go into my box of random washers. I can think of a lot of uses for washers of this size in phosphor bronze with a 3/8 of an inch diameter hole in the middle. It's quite cold in my workshop today, so I'm having to take very fine cuts to start with, because the lathe is slowing down. In a short while though, the mechanical system warms up and everything's okay again. I used to have the same problem with my Smart & Brown 1024 model when it was cold in the workshop. Because I was taking such fine cuts, it took me a while longer to make the part. But thankfully there's no rush, because as I'm doing this job, it's giving me time to think about other jobs on the locomotive. This material is cutting quite well. Mind you, it is a new tip on the tool. There's nothing special to mention about this simple turning operation. It's warming up now, I can take deeper cuts, but the final cut is much finer. After turning this to the finished size, the next thing to do is to drill the hole in the middle. First of all using a centre drill in the tailstock chuck, followed by a 3/8 of an inch diameter twist drill. And now it looks like this. I've parted off one washer, this is the second one, and I use the first washer to gauge the thickness for the second one. Anytime now this washer is going to fall off into the chip tray to join the first one. In this clip I have one of the washers in the hole in the frame, and it's all moving about because I'm moving the boiler into the correct position. Once the boiler was in the correct position, I just screwed in the blowdown valve. If there are any armchair engineers out there getting ready to write in, I would really recommend that you watch this particular video to the end. With the blowdown valve holding the boiler in the right position, this is what it looks like underneath. As you can see, it's still not touching the frame stretcher, because it mustn't do this. When the engine is back together and the boiler is in steam, all of it will get slightly bigger, especially the length, so you have to accommodate this when you mount the boiler. This is one of the two pieces of metal that I cut that's going to support the boiler, and it's time to mount the first one in position. I measured the position of the one that you've just seen and transferred the measurements to the frame at the top side. I centre punched the holes first, and here I'm using my small Bosch electric drill to drill a 3/16 of an inch diameter hole through the frame. And here I'm rotating the wheels to move the coupling rod away from where I'm going to drill the second hole. In this clip, if you look at the top of the frame, you can see where the original bracket was fixed to the frame, which held the old boiler in place. But the old boiler, which is now scrapped, had some mounting bars silver soldered to the copper boiler firebox. I certainly don't want to be silver soldering anything to this boiler, nor do I want to be drilling it and threading it for a bracket to be bolted to the firebox side. And that is why I'm doing the job this way. I finished the drilling of the holes, brushed away all the swarf, except for one tiny piece which is currently embedded in my thumb and is causing me some pain. But one has to suffer for one's art, darling. The next job is to thread the metal bar to take these two 2BA bolts. This is a relatively simple job. I hold the metal bracket in position up against the boiler and use a felt tip pen through the holes to mark the positions, Then I drill them on the drilling machine, and here I'm preparing to tap the holes. The holes are drilled tapping size for 2BA, which in this case is 5/32 of an inch. When you do jobs like this, really take your time and make sure that the tap is always at a perfect 90 degrees to the work. If it isn't at 90 degrees to the work, obviously the bolt won't go in straight, but also it will get more difficult to thread the metal if it's off-centre. I managed not to snap off the tap, and here I'm making a mark on the metal, very similar to the one on the sign to the gates of hell. Have I drilled the holes in the right place and have I threaded them properly? Well, the first bolt's gone in okay, and not unsurprisingly, the second one is doing the same. I then use the socket to screw them all the way into the bar, and on top of the special screwdriver I have one of these ratchet things, because these bolts need to be quite tight as I don't want them to work loose. This is the second steel plate, and this one's also been drilled in the drilling machine, ready to fit. I've turned the engine round, and this one that you can see is the one that I've just bolted to the frames. And as you can see here, the bolts are just the right length. They do not stick out of the piece of steel. If they were too long, they would foul the ashpan, and I don't want that to happen. So I did exactly the same with the other side, and now I have two brackets that support the boiler. I've removed the phosphor bronze washer, and here is the blowdown valve screwed into the boiler. The outer firebox wrapper and the foundation ring are now resting on the two steel supports. And with the blowdown valves in place, you can't lift the boiler off the frames, but it would move up and down. So what's the plan? Well, it's simple. Here is my box of silicone steam grade O-rings. I've selected a couple of O-rings like this, which are perfect for the job. After fitting the blowdown valves, I fit the O-ring, as you see here. And this solves any potential movement problem. When the engine is in steam and the boiler is hot, it can move around because it will compress the silicone O-ring, and it holds the boiler perfectly and firmly in place. And furthermore, I haven't pinched this idea from anyone. This is an original Keith Appleton modification, and I'm sure it will work fine. That concludes this episode. Stay healthy, thanks for watching, Merry Christmas, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.